Now let us discuss another model problem. See, here is minus 4 coulomb charge is there. Here is plus 9 coulomb charge is there. Then where should be the null point? You see, obviously the field of this 4 coulomb is this side, field of 9 coulomb is this side. Then after going away, this field decreases rapidly, and if the charge is more, somewhere here the field, it observes this plus 9 charges is this side and minus 4 will be in this direction. Both will be equal. At this point, the field becomes 0. Here, if these two charges, let us say minus 4, and the distance will be something else, let us say, okay, 10 centimeters, let us take. Right. Now, if this is plus 4 coulombs and this is plus 9 coulombs, both are positive, then where should be the null point? See, this is here and this is here. Somewhere here you will get the null point where the field becomes 0. Both are equal and opposite. So here also 10 centimeters let us take. Now the question is, at what distance the field becomes 0? This is case 1, this is case 2. In two cases we need to solve. You know, in general method you can solve easily, right? So usually this is outside, this is inside. Now after solving, use the same method. If it is q1 and if it is q2, if the distance between them is r, then find where the point will become null, where the null point exists or the electric field becomes 0. At what distance electric field becomes 0? You try for this, because the field acting here is equal to the field acting here. That is 1 by 4 pi epsilon naught into q by q1 by x square must be equal to 1 by 4 pi epsilon naught into q2 by r minus x whole square, because the field due to the first charge is equal to the field due to the second charge. So that is how we will get the equation. Both will get cancelled, and here r minus x whole square by x square must be equal to q2 by q1, and here you can say r minus x by x is equal to square root of q2 by q1. Then r by x minus 1 must be equal to square root of q2 by q1, and r by x is equal to square root of q2 by q1 plus 1, and finally you can write x is equal to r divided by q2 by q1 plus 1. And the second case, if it would be the minus sign, if q1 is minus sign, then obviously plus x here it will become plus x plus 1, then there it will become minus 1. Right? Let me write. If q1 is equal to negative, q1 is negative charge, then you can say x is equal to r divided by square root of q2 by q1 minus 1. Now here the conditions you have to understand, that q1 is less than q2 and x is from q1. Second condition, q1 is less than q2, and if q1 is positive, x is in between q1 and q2. If q1 is negative, x is outside q1. These things we can understand here. Clear? Right. Dear friends, good morning. Yesterday I gave you one problem. Hope you tried to solve it. Now let us discuss that problem. Now you see, this is x-axis. On this x-axis, at the point 1, 2, 3, 4, 5, 6, 7, 8, and so on, charges q are there. And then it is asked to find the resultant electric field at the origin O. This is question. Now, in this there are two concepts we are using. That is vector sum of electric fields, first point, and the formula for the electric field. Third, mathematical simplification. So here, given the formula E is equal to E1 plus E2 plus E3 plus E4 plus and so on. So that is equal to 1 by 4 pi epsilon naught is common, and all these are positive charges. The electric field will be in the same direction. So we add them. Then what happens? Q by 1 square plus Q by 2 square plus Q by 4 square plus Q by 8 square plus and so on. So that is equal to 1 by 4 pi epsilon naught into Q into 1 plus 1 by 4 plus 1 by 16 plus 1 by 64 plus and so on. Now if you observe this, this is in geometrical progression. Sum of infinite terms in this geometrical progression, sum of infinite terms is equal to a by 1 minus r. Here a is equal to first term 1 and r is equal to common ratio 1 by 4. Substituting this value, s infinity is equal to, we get 1 divided by 1 minus 1 by 4. That is equal to just 4 by 3. Therefore, we write electric field E is equal to electric field E is equal to 1 by 4 pi epsilon naught into Q into 4 by 3. That is equal to 1 by 3 pi epsilon naught into Q. Or simply you can write Q by 3 pi epsilon naught. This we can understand from this. Now for you, there is a homework in the similar fashion. the different problems you see here. This is charge Q, and at 2 charge 2Q, at 4 charge 4Q, and at 8 charge 8Q. Then it is asked to find the electric field at the origin. At origin 0, 0. If alternative minus are there, this is the second model, and third in this. If in the above problem, in this and this also, alternative negative, positive and negative charges are placed. Then E is equal to how much? This is the question. You can try for those things. Okay? Right.